All right, so the next topic is to do what is called orbital diagrams. And to do orbital diagrams, you have to have electron configurations. And so these are actually ones that we've done before, should have done before. Maybe you skipped one or two of them. So what I'm going to do is I'm going to write the electron configurations for these three elements, and then we're going to write their orbital diagrams out, and I'll go over what the rules are, okay? So here they are, and what we'll do next is we're going to draw the orbitals out. Now, remember we did like 4s2, 3d6, right? But the d orbitals are actually comprised, the d subshell is what we call it, is actually comprised of 3 orbitals. And the listing of the number of orbitals in each subshell is given down here. That's the 1, 3, 5, and 7 we talked about, the odd numbers. So what I'll do is I'm going to just draw for the outermost highest energy electrons we have right here, and we're going to do this. We're going to say 4s, and then we're going to go 1, 2, 3, 4, 5. This is 3d, and I'll put a line here so to designate between the two orbital types, because otherwise it can get confusing. And then we're just going to place those electrons in here. Now we use arrows, it turns out. There's this term called spin, spin up and spin down. It's a property. We don't really know that they're spinning, but it has to do with their magnetic fields. Electrons turn out to have their own little magnetic field, and we say they're spinning up or spinning down because of that. You always have to pair them so that if you're going to pair them, they're going in opposite directions, okay? So now we're going to put the d orbitals electrons in, and I have 6 of them. So the way it works is you will put them in their own rooms first, right? So think about like if you had 6 hotel rooms and nobody's married. Yeah, no monkey business is going on. I guess I got to clarify. And you had the opportunity for 6 people to fit into 5 rooms, right? They'll all most likely, it's weird when you put humans in these things. They'll all most likely take their own room, right? It was my kids for sure. They'd each take their own room, right? So I have 6 kids. They would each take their own room, but the only problem is there's only 5 rooms. So what's going to happen? People are going to have to pair up, and most likely it'll be the youngest ones pairing up in my house, and then the oldest ones would all have their own rooms. That's kind of how it works in houses sometimes. So the rule is this. This is electrons are represented by arrows. When Hund's rule is the rule that says when you put the electrons in orbital, you keep them unpaired first, and then when you pair it, you have them spinning in opposite directions or pointing in opposite directions. So this would be the orbital diagram for iron. For nitrogen, we'd write just 2s, and then 2p like this. Again, I'll put the line in between here. And then we'll put the 2 S's in like this. And then for nitrogen, right, there's 3 rooms and 3 children, right? So each one gets their own room, like that. I'm actually one of those parents that believes having to share a room is good for you. I'm one of those mean dads. And then we're going to go like this for this one. And I want you to put the children in the room, please. I don't want to have to talk to him again about this. So I'm going to pause it. Sorry. And you fill it out. And that is the orbital diagram right there. And the purpose for doing the orbital diagram is to show how many unpaired electrons there are. So we have things we call paired electrons and unpaired electrons. And so we have I'm just going to use colors, right? We're going to put a box around the unpaired electrons. These are the unpaired electrons for this one. These are the unpaired, and these are the unpaired. And the paired then obviously are 2, right? So they're the ones that are full.